All right, welcome. I want to go over a few things with you before we talk about partitioning a line segment. So first I want to talk about doing the midpoint with a formula. So the midpoint formula is x1 plus x2 over 2, and y1 plus y2 over 2. Again, you can remember this is the average. So it's the average of x, and then the average of y. So negative 4 and 15 will give you positive 11, divide that by 2. Positive 8 and 2, that will give you 10, divide that by 2. You get this fraction or decimal, however you want it. 11 over 2, 5.5, 5.5. All those are good. The y value must be 5. All right. Second thing to just refresh before we talk about partitioning is going to be midpoint with the step method. So the midpoint with the step method, we figure out the distance traveled in x, and then we do half of that distance. We figure out the distance traveled in y, negative 32, and we do half that distance of negative 16. So when we subtract 1.5 from 7, we'll get 5.5. And when we subtract 16 from 10, we'll get to negative 6. Okay, so that is stuff from chapters 1 and 2 that we just want to get back to. And what I want to work with you on is the modified step method. So we're going to go to our starting point for number 1, which was 4, negative, and positive 8. And then we're going half of that distance. We're going halfway, and then the number here is, that's going to be plus 19. And so we want to travel half of that distance and add that to the negative 4. And then for the y value, we're traveling 6 negative, and so that's the value that we need to take half of and then add to 8. And so our final answer here is going to be negative 4, and that 0.5 is going to make a 5.5. And then half of negative 6 is negative 3, and so that's going to get you 8 minus 3, which is 5. And so that gives us the 5.5 and the 5 that we had for number 1. Would you go ahead and see if you can work out number 2 in that same way? Again, we're trying to travel half of the distance. And the numbers that we're interested in this case are this 3 and this negative 32. So 3 negative and 32 negative. And this is going to be the exact same math, just done in a little bit of different format. It's going to give us a 7 minus 1.5, which is 5.5. It's going to give us a y value that's half of negative 32 was the same negative 16. To give us the same negative 6. So there's 5.5 negative 6. Okay. This would be another way that you could find a midpoint, and it bridges us to what we need to do with partitioning a segment. And then there's one more pre-topic before we really get into partitioning a segment. It's that we need to convert a ratio to a fraction. And so if we have a ratio that's a to b, we need to convert that to a fraction. So 4 to 7 converts to 4/11ths. And 5 to 3 converts to 5/8. And hopefully you can kind of see a pattern there and see where those numbers are coming from. If not, let me work you through it. So one thing we can do is we have total pieces here. We have 6 and 3 together. We have 9 total pieces. And then we put the front number 6 on top. Whenever we have a fraction or ratio, we want to reduce it. So in this case, we get 2/3. Instead of doing 6 to 3 and then changing that to a fraction first, what if we reduced it first? Well, we divide out by 3, we get 2 to 1. And then if we converted that to a fraction, there's 3 total pieces, and we want 2 of them, the front number over the total. And so in the general sense, a ratio of a to b, we want a over a plus b, and a plus b is the total parts. Total parts. All right, so thanks for joining me for the preview, and we'll get into it here shortly.